Hello and welcome to Foundations for Algebra, Unit 3A, Lesson 8. Today's objective is scholars will use multiple transformations to create congruent and similar figures. So let's talk about what is the difference between something being congruent and being similar. Congruent means exactly the same in shape and size. So we create them using translation, rotation, reflection. That's why these are called the rigid transformations. Rigid means unchanging. We can make similar figures. Those are figures that have the same shape but different size by using dilation. So congruent means exactly the same. Similar means same shape with a different size. So remember, in dilation, we can make a small triangle turn into a big triangle. So they are similar but not the same. So what do we mean by multiple transformations? Well, that might be reflecting and then translating, rotating and then reflecting, translating, then dilating, reflecting, then rotating, then translating. Any combination of transformations is multiple transformations. So let's look at this question. We have an alumni center. So a university has an alumni center at the location shown. And you can see the alumni center right here. They are considering relocating it to one of the alternative locations shown. Each unit on the grid represents 10 meters. So this is our first question about this. Can the university move the alumni center to location A without changing the size or shape of the building? So can we move to location A? So let's look at comparing these. Our alumni center looks like it is 4x4 with a 2x2 attached. When I look at the alternative location A, it is 3x4 with a 2x2 attached. So can I move it without changing the size or shape of the building? Think about that for just a minute. Of course, the answer is no. The two locations are not the same. Are not the same. And you can also see that if you counted the number of squares that were included. So the answer to that first one's no. The two locations aren't the same. Next one asks, can the university move the alumni center to location B without changing the size or shape? So again, we have our alumni center here. Location B is right here. So take a minute, pause the video, and see if you think they are the same. So hopefully you pause the video. So the answer is yes. They can. So now let's think about what transformations it would take to change that alumni center to the new location. Well, I look at it and I can see that I'm going to need to turn it because in this one, this part that's sticking up is up top. Over here, it's down here. So I would need to rotate it. I would need to go this direction. So I would need to rotate it this direction, and that is clockwise, 90 degrees. So we would have to rotate 90 degrees clockwise. I think I put 1 too many things on that. Sorry, let me undo that W, sorry. Clockwise. And then I would need to translate it down to the location. So that'd be pretty easy. We could just turn it and then move it down. Okay. Well, now let's think about this next question. We are asked to list the vertices. The vertices just means the corners of a figure that represents another alternate location for the Alumni Center. We have to describe a sequence that contains at least one rotation, one reflection, and one translation that shows the congruence between your figures. Okay, so I think it's easiest to start out by just doing this. So let's think about where these points are right now. So I have this point here. That's the point 2, 2. I have this point here. That's the point 6, 2. I have this point here. That's the point 6, 6. I have this point here. That's the point 4, 6. I have this point here. That's the point 4, 8. So we have lots of corners, right? And I have this point here. That's the point 2, 8. Okay, so that's the first thing. We have all of our points. So now let's think about what would happen. Let's think if because we need to do a rotation, or reflection, and translation. I want to do the rotation last because it's the one I don't like doing the most. So let's take all of them. And first I'm going to reflect. So do I want to reflect over my X or Y? So I'm going to reflect over my X-axis. That means it's going to go down. So I'm going to just move these points here. So when I reflect, I get a point here, 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 and a point here. So that's my first thing. So that's my reflect. As I can see, I got the same shape. Then I'm going to translate left 2, and up 2. Put me in a nice corner and make it a little bit easier for my rotation. So let's do this one in green. So here all my points go there, 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 there. So that is my translation. And then I'm going to rotate 90 degrees clockwise. I'm going to do this one in blue just because it's easier to see. So when I rotate it 90 degrees clockwise, this point here is going to come over to here. So instead of being 6, I'm going to go over 6. 1, 2, 3, 4, 5, 6. So I have that point, this point, this point, this point. So here is my new figure. Now I need these new vertices. So, and I'm going to write these vertices in red just so they're easy for you to see. So my new vertices are, are 0, 0, negative 6, 0, negative 6, negative 2, negative 4, negative 2, and 0, negative 4. So I can see my new vertices. Okay? So remember, we just move it. All of those involved me using these similar making congruent figures. Let's look here. Last problem. Describe a combination of two transformations that would move figure ABC, that's this one over here, to the image of figure ABC, the primes. Then describe a combination that would move it move the other direction. Okay, so first, to get from ABCDE to the image of ABCDE, I could reflect over the y-axis and then translate it down. Okay, so that's the first one. Reflect over, over y, then translate down. That would be the first one. I could also reflect over the x, which would move me from here. It would just move it down. And then reflect over the y. That would do it. Okay, so that gets me from ABCDE to the image of ABCDE. Now let's talk about going the other way. Well, I could just reverse these. I could translate up and then reflect, or I could reflect then translate up. Lots of options. So you come up with two ways to get from the figure here to the figure here. Okay, do that on your own, and I will see you all in class.